Bonsuelo Mathletes, the start of another chapter. Just a quick word of warning. This chapter is going to fly by. It's very, very short. We're going to have a midterm in just about a week or so. So make sure you pay attention to the schedule. What we're going to do this chapter is we're going to look at what are called systems of equations. Now, before I'm going to scribble some stuff on this page again, don't write it down. What do I mean by that? Okay, let's say I give you this. X plus 2 equals 7, and I ask you to solve that. What am I asking you to do? Find all the values that can be substituted for the variable x that will make that statement true. Okay, you should pretty much be able to say that in your sleep. Okay, what if I give you this? 2x plus 7y equals 13. And I say graph that. What am I asking you to do? Find all the values, all the xy pairs that can be substituted for the variables that will make that statement true. In other words, what are you trying to do with an equation? You're just trying to make it true. Well, what are we doing here? Let's take a look at this example at the bottom of the screen here. 2x plus 5y equals 3. Do I want to make that true? Yes, I do, but that's not enough. It's not enough to make that true. The other equation, 4x minus y equals 1. Do I want to make that true? Yes, I do, but that's not enough. What you're going to do is find all values, in this case, all the xy pairs that may be substituted for the variables that will make all the given statements true. In other words, you don't want to just make the first one true, although you have to do that. You don't just want to make the second one true, although you want to do that. You have to make them both true. Okay, there are three ways we're going to do this. The first and the worst way is graphing. You're never going to do this by graphing unless I tell you to. So why are we starting off with graphing? Because it makes you realize what it is we're trying to do. And then the two main methods, which will be much more exact, will be substitution and elimination. So let's go straight for graphing first. Okay, what I'm going to do first is find everything that makes the first statement true. Okay, so what I'm going to do is graph this. It's in standard form. So I'm going to find the x and y intercepts. The x-intercept is 3/2, 0. And the y-intercept is going to be 0, 3/5. And I'm going to have to enlarge this thing somewhat because it's so small it's going to be hard to see. Okay, so what do we got here? We got 3/2, 0. And we got 3/5, 0, 3/5, which is right about there. Okay, so far so good. So we're going to find all the values that make that statement true. Okay, well takes up a big, that thing's so fat, takes up a big chunk of this. So basically that's what we've got. Okay. So that's everything that makes that first one true. Okay, well, how about the second one? On the second one, the x-intercept is 1/4, 0. The y-intercept is going to be 0, -1. So let's plot that. And again, I'm going to enlarge this in order to plot it. So we've got 1/4, 0, which is right about there. We've got 0, -1, which is right about there. And then we'll find everything that makes that statement true. And again, sorry about such a, if you do this, which you should be doing it on pencil, on paper, the line will be much finer. Anyway, so this is your first equation. Everything that makes that one true, and this is your second one. Well, if this is everything that makes the first one true, and the other one is everything that makes the second one true, then where's everything that makes both of them true? And what we're going to do is pick that point of intersection. Now, do the best you can, okay? What does that look like to me? I don't know, about 1/2, maybe about 1/3. Or you could say 0.5, let's say 1/3 would be about 0.3. I'll take either one, okay? But do the best you can. I want you to graph, if I want you to do this by graphing, to graph them and see where those intersect. Now, do they intersect exactly at 1/2, 1/3? Probably not. Or at 0.5, 0.3? Probably not. But you know what? That's what you get when you do it by graphing. You're going to get an approximate answer. That's why it's the worst way you can do it. So why do we do this? Because you want to know what it is you're trying to do. You're trying to find all points that make both statements true. And you know what? Sometimes something weird is going to happen. It's about all I can say right now. We'll get to that in a little bit. But when it does, you want to think back, okay, what could this mean? Because all I'm trying to do is find basically where two lines cross, and that's the point that will make both statements true. Okay? And that's basically the simple idea. On this, I have nothing else on this file. It's fairly short. The two other methods, substitution and elimination, are the more important methods in terms of actually finding a precise answer. But that should give you the idea. Hope that makes sense. If not, let's talk. Bonsuelo.